In this video, I will be explaining how to integrate using the substitution rule. The substitution rule is like the reverse or backwards chain rule. Recall that using chain rule, the derivative of f of g of x would be f prime of g of x times g prime of x. That would make the antiderivative of f prime of g of x times g prime of x equal to f of g of x plus c. However, if you look at an integral like this one, it would be really difficult to find the antiderivative of 2x times the square root of 1 plus x squared, and that's where a u substitution comes in. A u substitution is a way to recognize the antiderivative of a chain rule derivative. You make substitutions into the original problem, removing all forms of x. This helps transform a crazy-looking integral into an easier one that you can solve. To recognize when to use a u substitution, there will always be a function with its derivative inside the integral too. Whenever you use a u substitution, you substitute for the inside function because when you derive it, its derivative is already in the original problem. The first step is to look at the integral and choose a function to substitute for. In this case, you would want to let u equal to g of x because g of x is the inside function. And you see that the derivative of g of x, g prime of x, is on the outside. The second step is to find du. Derive u to get du over dx equal to g prime of x, and multiply dx on both sides to get du is equal to g prime of x dx. The third step is to make the substitution. U is equal to g of x and du is equal to g prime of x dx. So if you substitute u and du into the original problem, you would end up with the integral of f prime of u du. The fourth step is to integrate. After transforming the integral into a much simpler one, you can now find the antiderivative, which is f of u plus c. The fifth step is to return to the initial variable x. Because u is equal to g of x, the answer would be f of g of x plus c. Our first example is to find the integral of 2x times the square root of 1 plus x squared dx. First, we want to let u equal to the inside function, which is 1 plus x squared, and you might notice that the derivative of 1 plus x squared is 2x, which is already in the original problem. So when we derive u, we get du over dx is equal to 2x, multiply dx on both sides, and you will get du is equal to 2x dx. When we plug in the values of u and du into the original problem, we get the integral of the square root of u du. You could also see the square root of u as u to the 1/2, and that would help you antiderive easier. The antiderivative would be 2/3 u to the 3/2 plus c. Plug in the original value of u, which is 1 plus x squared, and you will get 2/3 times 1 plus x squared to the 3/2 plus c, and that is your answer. Our second example is the integral of x times sine of x squared dx. Like the last example, substitute u for the inside function, which is x squared. Derive u to get du is equal to 2x dx. Now notice that x dx is in the original problem. To get x dx, pull out the 2 by multiplying du by 1/2. Plug in the values of u and du into the original problem, and you'll get the integral of sine of u times 1/2 du. Now you can pull out 1/2 outside of the integral to get 1/2 times the integral of sine of u du. Now the integral is much simpler, and you know the antiderivative of sine of u, which is negative cosine of u, so if you integrate, you will get negative 1/2 cosine of u plus c. Plug in the value of u, and you will get the answer as negative 1/2 cosine of x squared plus c. Our third example is to find the antiderivative of 10x over 5x squared minus 8. Now in this example, there's not really an obvious inside function that you can do a u sub for, but you can figure out which one to u sub for if you recognize that 10x is the derivative of 5x squared. If you let u equal to 5x squared minus 8, its derivative would be du equal to 10x dx, which is already in the original problem. Plug in u and du into the original problem, and you would get 1 over u du. Now you have a much simpler integral to solve for, and you know that the antiderivative of 1 over u is equal to ln of the absolute value of u, so the antiderivative would be ln of u plus c. Plug in the original value of u to the answer and you will have ln of the absolute value of 5x squared minus 8 plus c. Our fourth example is the integral of sine of x divided by cosine of x to the third. This one can be tricky at first because the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x, so you may not know which one to use sub for. So if we substitute sine of x for u, we would get du is equal to negative cosine of x dx. This would mean that we would need cosine of x times dx in the numerator, but in the original problem, cosine of x is in the denominator, so this method would not work. Now if we substitute cosine of x for u, du would equal to sine of x dx. Sine of x dx is in the original problem, so cosine of x as u would be the better choice. Now if we plug in u and du into the original problem, we would get the integral of 1 over u to the third du. An easier way to look at it is the integral of u to the negative 3 du. Now you can easily find the antiderivative, which is negative 1/2 u to the negative 2 plus c, or it's negative 1 over 2u squared plus c. Go back to your original value of u and plug it into your answer, and you will get negative 1 over 2 cosine of x squared plus c. Our fifth example is the integral of 2x plus 2 times e to the x squared plus 2x plus 3. Notice that if you chain rule e to the x squared plus 2x plus 3, you'd get e to the x squared plus 2x plus 3 times 2x plus 2, because the derivative of x squared plus 2x plus 3 is equal to 2x plus 2. So if you let u equal to x squared plus 2x plus 3, du would equal to 2x plus 2 dx, which you can see is already in the original problem. Now if you plug in u and du, you will get the integral of e to the u du. The antiderivative of e to the u is e to the u, so the answer would be e to the u plus c. Plug in the original value of u into your answer and you will get e to the x squared plus 2x plus 3 plus c. So to quickly summarize, the substitution rule is used to create a simpler integral that you can easily solve. Always use sub for the inside function or the function that has its derivative within the integral. Remember to change all forms to u and du and remove all forms of x and dx in the new simpler integral. Then integrate and plug in your original values for u, and you have successfully used the substitution rule.